Have you been creating all of your code inside of your main method so far? If so, it's time to level up those skills and learn about methods. Methods are one of the core aspects of an object-oriented language like Java. In the Java language, all of the actions that your application performs live inside of methods. Every print line, every conditional statement, those all have to live inside of methods. Now, imagine you have a large application that's hundreds of lines long, or even thousands of lines. What if all of that code just stayed inside of your main method? That would be completely unreadable, and over time, very unmanageable. Methods allow us to break down our code into smaller chunks and keep our code clean and readable. Let's dive in and take a look how they work.
The method is fascinating.
Okay, I have my project up and I've called it methods. Inside of my project, I have my source directory and a main class. So here's my main class with its opening curly brace and its closing curly brace. Hopefully by now you know that all of the code that we create in Java has to be inside of a class. And so far, maybe all of the code that you've created has been inside of your main method here, right? With its opening, so between the opening curly brace and the closing curly brace, right now, all I have this system.out.println that says hello world. What if we want to create our own methods? First of all, let's talk about what a method is. A method is a chunk of code that executes when it's called. That's the definition. Let's start creating a method, a very simple method. So we'll have a method that just says hello to a user. I'm actually going to remove this print line. We don't need that. Okay, so we'll say public static void. And then the name of our method, we'll say greet user. We'll have a print line that says hello user. Okay. So we have a few keywords here, public static void. Any keyword that you see will be in this orange color, right? So public, this is used for any method that you want to be accessible from a different class. The keyword static we'll get into later. We'll cover that when we cover objects. Void, we'll also talk about in a few minutes. For now, we'll just write this keyword void. And then we have our name of our method. The common convention for naming a method is that it should be an action because methods perform an action or a task. So here we call this greet user. To run this method, we'll go inside of the main method here. And again, the method is a chunk of code that executes when it's called, right? So in the main method, we'll just call our greet user method. So we'll just say greet user. That's all we have to do in order to get this to run. What if we don't do that though? Let's leave that out and then try running the application as is. So I'm running my application and it's running the main method, but there's nothing inside of here. So we don't actually get any print statements in the console. All right, but if I do invoke this method and then run it, now I see my print line that says hello user. A method can handle multiple tasks. So if I have a method that has multiple print lines, I'm just going to copy and paste this. So now I have this method called enroll student into classroom. So imagine this is Canvas or some kind of LMS, right? I have my print line that says check if student ID exists, and then check if the classroom ID exists. Another print line that says check if the classroom has space, right? Make sure the classroom isn't full. And then if it's not full, enroll the student into the classroom. And lastly, tell the user the update was successful. So again, to run this method, we'll invoke or call the method in our main method. So we'll say enroll student into classroom, and I'm just going to click enter to let it autocomplete. And before I run this, let's undo that for a second. Notice how before I invoke my method, the name of this method here is in gray. This is to tell us that this method, although we've declared it, it's not being used anywhere. So that's what the gray coloring means here. As soon as I invoke that method, enroll student into classroom, now it's turned blue. Okay, let's run this. It's cool. So now I get all of these print lines from this method. So why would you use methods instead of just having all of your code inside of your main method? For a couple of reasons. A common reason, or one of the biggest reasons, is that it allows us to keep our code modular. So imagine an application that's hundreds or thousands of lines long. If everything was in the main method, it would become very cumbersome and very difficult to manage over time, as I said earlier. So we can keep our code modular by breaking it down into its smaller components by having a method that represents each of those components. Methods are also useful if we have a task that we're going to run multiple times. So imagine, let's say we have a database from which we need to identify whether IDs are valid, right? So a user logs in, we want to, or maybe a user ID is requested, right? We want to check if that ID is valid, right? And then you also have classroom IDs, right? We want to make sure classroom IDs are valid if a classroom is requested. So that same method for checking whether an ID is valid, you might have you might put that inside of a method instead of just having it along with the rest of your code, right? So you'd have a separate method called maybe validate ID or something like that. Okay, let's give you a challenge. Now that we've gone over a couple of methods, I'd like you to try this out on your end. Create a method called square area. Inside the method, create a variable called square height and assign it a value of 10. Print the area of the square by printing square height times 2. And actually, as I said, these should be actions. So instead of square area, let's call this print square area. All right. All right. And then, so it should print the square height, that variable times 2. And then, actually, square height times square height. And then invoke the method in main. Okay, go ahead and pause the video here before we go over the solution. All right, and then once you're done, go ahead and unpause. And here's what the solution will look like. So we'll say public static void, and again, we'll call this print square area. And here, we're just going to create an integer with the value of 10. So int square height equals 10. And we'll run square height times square height. All right, so there's our solution. Let's also invoke it in main. So up here on line 5, let's invoke print square height, right? Because without the invocation, that's not the method won't run, right? Okay, so let's run this. Cool, so there we see 100. So these are a couple of very simple methods, right?
Surely there are better methods than this.
Yes, they are, Captain Kirk. Let's take this up a notch and let's talk about parameters. So parameters act as variables inside the method. They allow us to pass data to a method. Here's what this looks like. So we'll say public static void, and here we'll have a method that greets a user, but this time, instead of just saying hello user like we did before, here I'm actually going to allow the user to pass their name to this method. So we'll call this public static void. We'll call this greet user2. And this time we'll add a parameter. Parameters go inside of these parentheses, and they start with the data type, just like we're creating, as though we're creating a new variable, right? So we specify a data type and then the name of the parameter. And then here, inside of the method, we'll just say hello plus user. So here we'll use string concatenation to say, to print this string hello along with whatever string is passed that represents this user. All right, let's invoke this method. So we'll invoke greet user2, and we can pass any string for a name that we want, like Zaphod Beeblebrox. Okay, so once we run this, let's see what happens. Cool, so it prints out hello Zaphod Beeblebrox. So this string, Zaphod Beeblebrox, is used to be set as the value for the user parameter. So at the time that we invoke the method, up on line 7, this string gets passed to the user parameter. Right? So every time we use that parameter inside of the method, this refers to whatever string gets passed to that user. Right? So we can try it out with a different name also. So let's say greet user2, and we'll say Farhad Ahmed. And now that string, Farhad Ahmed, will be used to be set as the value for the user parameter in that invocation. All right, so now we're passing parameters. We can also pass multiple parameters and of any data type, right? So we can say, let's create another method. So we'll say public static void greet user 3. And this time, let's take a user's first name, last name, and their age. So we'll say string first name, string last name, and an int for the user's age. And we'll do a print line that says first name plus an open space plus last name plus is plus age years old. All right. Let's invoke this method. So again, I'm specifying that this is a public static void method. The name of this method is greet user, and we have 3 parameters in this method. So we have one parameter that says string first name, the second parameter is string last name, and the third parameter is an integer to represent the age. And in this print line, we're using the parameter first name and then concatenating an empty string, or rather a blank string, plus the last name, plus is, and then the age, plus years old. Let's run this. All right, so I'm going to invoke, so I'm back in my main method. I'm going to invoke greet user3, and we'll pass master Yoda. Pretty sure master is his first name. And he's 900 years old. Let's run this. Master Yoda is 900 years old. Okay. A common mistake that is made when people start learning about methods is that they'll create methods inside of methods. In the Java language, you cannot have a method declaration inside of another method. So that's why you see this separation where from lines 2 until 11, this is my main method, right? This is my closing curly brace and my opening curly brace for that method. From lines 14 to 16 is my greet user method, right? Lines 18 through 24, this is my enroll student into classroom method. And then the next method, right? So these are all separated, completely separated from each other. It's also best practice to leave at least one empty space. Actually, I shouldn't say at least. It's best practice to leave one or two empty spaces between each method, right? So that's why you see these separations. I'm going to remove that separation. Cool. And then I have my last two methods, my greet user 2, that's the block, and then greet user 3, right? That's that block of code. So this is how we can use parameters to pass values to methods. All right, let's talk about method overloading. Again, I'm going to copy this. So method overloading allows us to create multiple methods with the same name as long as they have different parameters. Here are a couple of examples. Let's say we want a method to print the area of a rectangle, right? A rectangle might have two different, like a different size for the length and width, or it might have the same length and width, right? In which case it would be a rectangle, a square, right? So let's say public static void print rectangle area. And this will take a double for the length and a double for the width. And then we'll do a print line for length times width. So what this method does should be pretty straightforward. It takes the parameter for the length and the parameter for the width. And in this print line, we're just taking those parameters and just multiplying them by one another, right? Doing length times width. If I run this, let's say print rectangle area, and let's say 8 and 5. So 8 times 5 gives us 40. Since these are doubles, let's just change that to 5.5. Cool, we got 44. Okay. With method overloading, I can have another method that's also called print rectangle area as long as the parameters are different. I'm going to copy and paste this. And let's say, okay, I'm getting an error right now. Let's hover over this. So print rectangle area, double and double. So a method of this name along with two doubles is already defined. If I just remove one of these, now the parameters are different, right? So this will work. So now I can invoke this method, or I can declare this method of the same name, have a double of L, and have this print L times L. All right. Let's invoke this as well. So we'll say print rectangle area, and I'm again going to pass 8. So the compiler knows because the arguments that I'm passing for these methods are different, right? So on line 12, I'm passing two different pieces of data. On line 13, I'm only passing one. This is how the compiler knows which method I'm trying to invoke between the two. So let's run this. Cool, so I get 44 up here and 64 over here. Now let's actually say 8.2. Run that. Cool, so now I get 67.24. Okay, so that's method overloading. All right. I'm going to give you a quick challenge again. Now that we've covered parameters as well as method overloading. So I want you to create a method called getCircleArea that takes a radius as a parameter. Inside the method, calculate and print the area. This is the formula. Area equals pi times r squared, radius times radius, right? Pi r squared. So I'm going to give you, go ahead and pause this and then come back once you're done. Okay, let's go over the solution. So we'll say, again, public static void. And again, look at where I'm typing this, right? I have one closing curly brace below this, and that's to close my class. And if I click next to this, I can see that the main public class main, this is highlighted up here, right? That's how we can tell which block of code this curly brace is closing, right? So make sure as you're practicing your methods, you're not making the mistake of creating methods inside of other methods. So it's very important to keep track of which curly brace is opening or closing which block of code. All right. We'll say public static void getCircleArea. I like printCircleArea better. Let's call this printCircleArea. printCircleArea, and this takes a double radius. All right, and we'll just print out 3.14 times radius, so radius squared, right? This is fine if you write it this way, but if we're using pi, there's actually a better way to handle this. We can actually use math.pi, and actually, let's take a look at the value. So this is slightly more accurate than just saying 3.14, right? So this says 3.14 and then the first few numbers of pi times r times r. All right, I'm going to comment that out. Okay, let's invoke this method, printCircleArea. Oops, not that one. printCircleArea. There we go. And the area is 10.3. All right. So here's my circle area, 335. Point whatever. Okay, so this is how we can create methods that take parameters and that are overloaded. Let's talk about methods with return statements. All right. Methods with returns. And again, I'm going to copy and paste this. So the return keyword stops the execution of a method and can return a value from that method. So far, when we're running methods, we've just been using this print line. And this is okay. This takes whatever content we want and prints it to the console. This is a great way to test our methods and double check that they're working the way that we expect them to, right? But in a real world application, you're not going to use that to present data to a user. So for example, if you're logging into Chase Bank and Chase's backend server is trying to grab your account balance, it would be useless if they just took your account balance and printed it to the console, right? What they would actually have to do is create a method that returns your current account balance and sends that to the front end. And then the front end, their website can choose to do whatever they want with it, right? They can display it in on your profile page or do whatever they want, right? So this is one example of when returns are useful. Let's create a method called getRectangleArea And instead of printing it to the console, instead of printing the result to the console, we'll return the result. So let's say public static double get rectangle area. Actually, let me take that back. Let's keep it void for a second. Just because that's what we've created so far. So public static void get rectangle area. And again, we'll take a double L and a double width. And we'll say return length times width. Okay. When you're returning data in a method, so when you're sending data, when you're returning a value to wherever this method is called, here is where we specify the data type that this method is returning. So when we take two doubles, a length and a width double, the data type for this multiplication is also double. So here, instead of saying void, we'll say double because that's the type of data that's being returned by this method. Every time you're creating a method that's returning some value, you always need to specify what data type is being returned, so whether it's a string or an integer or a double, as in this case. Okay, let's run this. And just so it doesn't get conflated with everything else, actually, let's say this. Print of the rectangle with return. Okay. All right, and then we'll say get rectangle area, and we'll pass 10 and 20.343. I'm immediately getting a warning over here. If I hover over this, it says the result of main, which is the class main, main.getRectangleArea is ignored. In other words, this is returning some value, but we're not telling the compiler what to do with that value. Do we want to send it to some front end? Do we want to take the value and print it to a console? Do we want to assign the value to some variable? So there's all kinds of things we can do with the value, but the compiler is telling us that we're invoking this method that's returning a value, but we're not doing anything with it. So if I run this, you'll actually see that nothing gets printed after this, right? So we see the print line for the print of the return rectangle with return, but we don't see anything after, right? Because again, this is only returning data. This isn't, we haven't specified what to do with the data that's being returned. So one thing we could do is we could put it inside of a print line. Let's do that. So we'll specify a system.out.println and toss this code inside. Oops, that's not what I meant to do. We'll toss that code inside of the print line. All right, let's run this. And now we'll see that the result is printed. 203.43, that seems right. Okay. We could also choose to assign it to a variable, right? So we can say double rectangle area result equals get rectangle area, and we'll pass the same thing, 10 and 20.343. And here, instead of printing, oops, I want to comment that out, uncomment for a second. Instead of printing directly the result of get rectangle area with those arguments, instead of that, I can do a print line for, and just pass the variable instead of the method invocation itself. So now, if I run this rectangle area result, you'll see that both lines 20 and 21 print out the exact same thing, right? We can either directly run this or we can run that and assign it to a variable and then print the variable, right? So either of these options work. Cool. So now we see two print lines that say 203.43. Okay, so the return statement can be used to return a value to whatever method is calling this the other method, right? So in other words, our main method is calling that get rectangle area method. So the get rectangle area method returns whatever value, the value to wherever it's being invoked. Okay, we've completed one example of when we are returning data to a method. Let's come up with another example. We can create a method that takes an entire array as a parameter. So we'll say public static, and this will return, let's create a method that returns the sum of the values in that array. So we'll say public static int get array sum, and this will take an array as a parameter. So this will take an array of integers, and this will return the sum of that array. And let's just comment out what an example of an array is. Let's say the array is 1, 2, 3. So inside of this method, we'll create a for loop that iterates through this array and updates and grabs the sum, right? So we'll start off by creating a variable to represent whatever the current sum is. So we'll say int sum equals 0. We're starting at 0. And then we'll have our for loop that iterates through this array. And as it iterates, it should update the value of sum with the value of whatever index we're looking at, right? So we'll continue. So our for loop will say I equals 0 to start at the 0th index of the array, and we'll continue until we get to the end of the array. We don't want to say, so let's say, so this array has how many indexes? 0, 1, and 2, right? Those are the index values. So we don't want to say less than 3. We don't want to specify the actual value here, right? Because by creating a method that is meant to take any array, this should work for whatever array size we pass it, right? So this method should work not just for this array, but should also work for an array of any size, right? So if we say 11, 22, 33, 44, it should work for this array as well. So instead of specifying a literal integer here, we'll specify r, which is the parameter name that we're passing here. We'll say r dot length. So now this will continue as long as we'll start with I equals 0, and it'll continue as long as I is less than the length of whichever array is passed, right? So now this will work for both of these arrays. Okay, and then for each value inside of the array, we'll say sum plus equals array I. And then sum. As we update the sum, by the time we get to the end of this for loop, this should contain the sum of all the values. So at the end of this, we can just say return sum. And in fact, you might have noticed I was getting an error there. If I hover over this, it tells me that I'm missing a return statement. So when we create a method and we specify a return type, it'll require that we do return that data type. Otherwise, it will throw an error. So here we'll say return sum. All right. Now, inside of our main method, let's do a print line for get array sum, just so we can separate this from the rest of our code. Okay, and then we'll create some array. Actually, let's use both of those two arrays that we wrote down below. So we'll say int nums1 equals 1, 2, 3, and int nums2 equals 11, 22, 33, and 44. And then let's just print out the result of the method invocation, get our sum, and the argument that we'll pass to get our sum will be nums1. And we'll run it again and pass nums2 the second time, right? So on line 26, I'm printing get our sum and I'm passing the nums1 array to that method. Next, I'm invoking get our sum again, and this time I'm passing nums2 this array as the argument to that method. All right, let's run this. Cool. So there's 6, right? 3, 4, 5, 6, 110. So that's 44 plus 33 plus 22 plus 11. Looks good. Okay, so these are methods that are returning data, but let's go back to that definition of returns. So the return keyword does two things, right? One, it stops the execution of a method, and it can return a value from that method. So far we focused on the second part, returning a value from a method, but we can also just use the return keyword to stop a method from, to end a method's execution. So in other words, while a method is running, if it comes across the return keyword, it'll actually stop the method. All right, let's go over an example of when we might use the return keyword in a method that doesn't return any data. I'm going to create a method here, and actually I don't need a comment. I'm going to create a method to represent the retrieval of a transaction from a purchase. So let's say public static, and we say void here because we're not returning any data. Although we're using the keyword return, because we're not actually returning a value, we're going to stick with calling this a void method. And we'll call this print transaction status. We'll say int. This will take a transaction ID as a parameter. Okay, so when a user passes a transaction ID, we want to make sure that the transaction ID is actually valid. So we can add an if statement that says if the transaction ID is less than or equal to 0, this is not a valid transaction ID, right? So we'll add a print line that says this is not a valid ID. And then return. So it doesn't continue with the rest of this method. And notice that it's grayed out right now. It's grayed out because, and it actually tells me, return is unnecessary as the last statement in a void method. So it's telling me right now I don't have anything after this method, after this statement. So the method is going to end there anyway, right? As soon as I add any other action, so let's add a print line. So already we see it's no longer grayed out, right? So now, if this return statement is run, whatever I have after this if condition will not get hit. It'll just close the method. It'll stop the execution of the method as soon as the return statement is seen. Okay, so if the transaction ID is valid, let's add a print line that just says retrieving your status from the database. And another print line, maybe this says your transaction status is whatever, right? Okay, let's invoke this method and see what happens when we pass a valid transaction ID, and also what happens when we pass an ID that meets this if condition, right? In which case, this block will be run. It'll run this this print line, and then it'll also run this return, and it'll stop the method there. Okay, let's try this out. All right. So I'm at the end of my main method. My main method, if it wasn't clear, this is where I'm invoking all of my methods right now, right? So inside of my main, this is where all of the invocations are. Okay, so we'll say print transaction status, and let's pass a valid number, 1244. And actually, let's also make a print line here that says transaction statuses. Okay, so if I run this, so we see our two print lines, retrieving your status from the database, and your transaction status is ... So that's what we have over here, right? So we have our if block that says if transaction ID is less than or equal to 0, which was false. So if it's false, it skips over the if block and just runs these two print statements. What happens if I pass an ID that is less than or equal to 0? Let's try that out. Okay, where's the bottom? Oh, there we go. So let's run this again. And this time we'll just pass 0. Okay, so the second time, so this was the two prints from earlier, but now because I passed 0, we just get one print line that says this is not a valid ID. And then it stopped there because the next thing that was right after that was my return keyword. So this is a situation where you might use the return keyword to end a method in the middle of its execution. All right, hopefully you found this video useful. If you are finding these videos useful, please do like and subscribe. It helps us out. I'll see you in the next video.